Shifting gears now, we're going to look at sampling and some issues that can arise. So here is example 11.1. There are a lot of words in front of you. Please take a moment, pause the video, and sample. In other words, circle 10 words. Doesn't matter what 10 words, but choose 10 words and circle them. And then come back. There are the 10 words that I chose. So you will use your words as we complete this, but I'm going to use my words. So let's start with identifying now the passage. Do you know what it is? If you said Gettysburg Address, you nailed it. So this is the Gettysburg Address. Suppose we want to characterize this passage by the proportion of words containing the letter E and the average length of words. We consider this passage of 268 words our population of interest. Notice that this is a finite population compared to the processes we studied earlier. So this population is fairly small, and you may be like, well, why are we, if we can actually find the exact average of all these words, why are we doing this? This is an artificial situation. We're doing this to show you that random sampling works. Okay. By the way, doing this, looking for the proportion of the words that contain the letter E and the average length of words as part of literary computing. So what's the observational unit in this population? And hopefully you think, well, it's each word, because that's what we're interested in. We're looking at words. The variables measured. Well, we're going to be looking at two variables that we're going to measure. The number of letters in each word, and we're also going to look at whether it contains E. So we have two variables. The first one, does it make sense to do arithmetic operations on, let's say, if you have one word that has 5 letters, one word that has 1 letter, another word that has 2, could you add those number of letters up and get an average? Yes. This is quantitative. Whether it has an E, yes or no, categorical binary. Do you think that your sample is representative of the entire passage? Do you think you chose words that represent every word in the passage? Don't know. It'll be interesting. We're going to investigate that as we go along. My gut reaction is probably no, but I don't know. I just chose words, so let's see what happens. For your sample, complete the following table. So I'll show you how to start that. For word 1, in this case, my word was this. It is 4 letters long. And does it have an E? The answer is no. So that takes care of word 1. Please do complete this. So civil, just do one more of mine, has 5 letters. And once again, it does not have the letter E. Please take a moment, pause the video, and complete the table for your words. So there's my completed table. You can see the length is the quantitative variable in here. Whether it has letter E is my categorical binary. Now it asks in part G to record the following for your sample: the average length and the proportion of the words with letter E. Well, we know that we have 10 that we did. We selected 10 words. To get the average length, I'm going to add up all of these together. So all of those and divide by 10, and I end up with 4.8. To get the proportion, I'm going to count how many actually have the letter E, and I've got 1, 2, 3, 4, 5. So 5 out of 10, so that gives me 0.5. Please pause and do that for your sample. Okay, in G, are those numbers reported statistics or parameters? And hopefully you think, oh, those are statistics because they're based on my sample. Okay, parameters are based on a population. The average length of all words is actually 4.295, and the proportion of words with an E is 0.466. Are these numbers parameters or statistics? Assign symbols to them. Well, these are based on the entire passage, all the words, so they're parameters because they're based on the population. We want to make sure we use the appropriate symbols for a population mean versus the population proportion. Mu is going to be 4.295, and P is going to be 0.466. Remember, these are different. These are based on the population of all the words. So we use mu and P. When we're looking at the sample, we're going to use X bar for the average and P hat for the proportion. Once again, this is an artificial situation because in reality, we know the values. We don't have to do any testing or anything on them. We don't need statistics. But we're doing this just so that we can see how values of statistics are related to the value of the parameter they're estimating, and also how to take a representative good sample. So what I would do if we were in class is I would take a moment and have everyone come up. I'd have a line like this with 0 up through 10. Let's see. And I would have you record your average on roughly where your average is. My average, so I'm looking here, we're looking strictly at the average length of words. Mine was 4.8, so I would put it close to 5. We know the population is 4.29. So record mine and record yours. Now, I'm going to pause the video for a moment and record what I had from a previous class. You don't need this exactly in your notes. I more just want you to see what typically it looks like in a class. So this is roughly what I got in the last class that I taught, and this is what it looked like. We know that that population average is 4.29 because we're told that. How would what would I label this chart? Well, this is the average length of each sample of 10 words. With regards to this dot plot, so looking at this dot plot that we have, what are the observational units here? And hint, it's not the words. Because remember, each of these X's, it varies from student to student and also student to professor, what average they got. So if you think about what was actually recorded here, it's each sample of 10 words. What's the variable? What's going to vary from sample to sample? And that's going to be the average length of the sample. And that is quantitative in nature. So now let's compare our sample statistics from G to the known, in this case, values of the parameter. I put 4.29 already in there. Do you think that this looks like we're close to estimating 4.29? Or do you think we have a lot more? I guess what I'm asking is, do you think there are roughly the same number of X's on each side of 4.29? And hopefully you say definitely not. We seem to be way higher. So I'd say that it is definitely bigger than 0.5. We're not going to do the actual count. You're welcome to in this class. Actually, you know what? I will pause and take a moment and do that up quick. So the question was, going back, this is how many were greater than. It's way more than a half. So it asks here's how many and what proportion of students in your class obtained a sampling average of less than. So less than would just be the complement. It's going to be 0.14. There were only 5 observations out of the 30 that were less than, and it ended up with 0.14. So that's pretty small number there. A sample is said to be biased if the sample statistics from samples drawn using that method consistently over or underestimate the population parameter of interest? Well, I'd say we consistently overestimated because 86% were more than the 4.29, whereas only 14% were less than. Based on K, do you think the sampling method of asking students to circle 10 words was biased or unbiased? Well, I would definitely say it's biased. If biased, in what direction? We are overestimating. Why did this happen? Okay. In class, usually I'd ask you, why do you think this happened? If I'm looking just at the words, what pops out at you more? The very small words like a or so, or the larger words? Well, the longer words tend to be, unless you're specifically thinking to do it, most students say that it's the longer words that pop out. Longer words are more visible. So what about some better strategy to take a sample of 10 words? Well, in the past, I've heard students say, well, you could close your eyes and then you could point at words. The problem there, though, is if you do that, are you still likely to land on the word a or the word like liberty? Well, which one has more area that you can hit? And the answer is liberty. But then some student will usually say, well, what if we do a random sample? And that's where we're going to head to in the next video.